Yeah, hello folks. I'm Samarth Patil, and today in this session we are going to see how to use the Lotus suspension analysis software, which is also known as Lotus Shark. So first of all, let's understand why this software is. This software is used for simulating your hard points. The hard points are basically the joints of the your suspension system where the control arm is connected to wheel knuckle and to the our chassis. Okay, so this simulating these hard points is really important to test your design of suspension system. So whenever you are going to validate your suspension data, your suspension hard points, it's required to simulate your hard points in any simulation software. So Lotus is one of the tool which is used mostly. So with this introduction, let's see the software and I will tell you things one by one. So this black area is basically where you will get to see what the simulation is running, and these are the tools, and this ribbon provides you have options. So let's start with the new one. First, before using this software, you should be ready with your suspension design. Means you should have your hard points, your suspension type, your suspension data, all this data. Which I am going to show you, which inputs are required, should be ready with you to start simulating the design. So this is just a validation or analysis uh, tool. Okay, so for let's do it for front suspension only for this time. So I'm going to select the double wishbone damper on the lower wishbone. You can also select other, it depends on which type of suspension you have used in your system or your vehicle. And we've already did front coordinates. These coordinates are basically the hard point orientation or hard point position, and the distance of them are relative to the origin of this lotus. Okay, so that's you all to also need to see what is the origin of this lotus and what is the origin of your hard points. Like might be you have done your hard points in Katia or any SolidWorks software, so the origin might be same, and this x y z coordinate might be different. So um, you have to find this relative to the lotus origin. Okay, uh, so these are the hard points. Also the name is mentioned like lower wishbone, front pivot, rear pivot. Also we need additional points like we need damper wishbone end, damper body end. Also we need few steering system points like outer track rod ball joint, inner track rod ball joint. We also need a wheel spindle point, wheel center point. Then we also need the CG. Okay, CG point. Why the here the part 1, part 2, part 3, part 4 is mentioned? Like we can also simulate using various CGs. Like while designing or while iterating, we might have different CGs. Like okay, so we can also shift from one CG to another CG. Like we can test our suspension system on the various CGs. So how to select CG and how to shift it, I will show it later. So for now, you should be or you should have inputted your hard points here. Okay. After that, we have to select the steering type. Okay. So steering type is steering box. So for now, I am going for steering rack. Okay. After that, we have to select the parameter data. So what is parameter data? This is again related to the your design of vehicle. So bump travel, rebound travel. So you are up to this stage, like you are validating your design. So it's obvious that you know these parameters, like what is bump travel, what is rebound travel, so and what is this bump oblique rebound increment. So this is related to simulation. This is not related to your design. So when you keep it low, your suspension will be slow. If you keep it high, like 50, then suspension will be simulation will be fast, sorry. So simulation will be shown fast, and the results will be shown in the step of 50. Like if you keep it 5, and if your bump travel is 60, then it will be shown as 60, 65, 70, 75, like that. Okay. So it's below. Okay, so it will go from 0 to 60 and in positive direction, and 0 to minus 60, okay, in negative direction. So it will, if it's 5, then it will be shown as 0 to 5, 5 to 10, 10 to 15. If it's 20, then it will be shown like 0 to 20, 20 to 40, 40 to 60. Okay. Then roll angle, roll increment also same as I explained about the bump increment. Then steer travel, it is related to steering system. Then steer increment, wheelbase CG height, then braking on front in percentage, drive on front. Okay. Then weight on front. After that we have to select the front brake types, like if it's inboard then 1, then out, if outboard then 2, and say similar for rear brake type. Total sprung weight, what is sprung weight? Sprung is basically the weight acting on the spring. Okay, so if we measure the total weight of the vehicle, then minus the weight of wheel knuckle and other assemblies which is not mounted above the spring, and then the the solution will be the sprung weight. Okay, so basically it's important to take sprung weight, because the sprung weight is acting on the spring. Then the front suspension type, as we have selected double wishbone, then it's by default it's 1. So that's also important to select. After that, uh, let's go to next, tire data. Okay, in the tire data you can see it's a visual purpose tools. You can change your color as well. Then you have to put rolling radius. Okay, then tire width, then vertical stiffness, spring diameter, and this is for resolution and all. You can change this data as per your requirement. Okay, and after that you can apply, or apply it. Okay, then go for set units. Okay, when you set units, you can see here, you can change your units from degree radian. Okay, so let's um, okay, so after clicking on done, we got a default. Okay, it is default, it is not designed by me. So I just want to show you how this software works. Okay, so that this point is your CG, and you can after you work in this software, you can understand like where is the origin of this software. See, this is the origin of Lotus, and this is our wheel. Okay, so if you want to again iterate or change your hard points, you can go on this option like front. You can get to edit all these things. If you want to change your parameter data, this option is there. If you want to change your tire data, this option is there. Okay, so these are the basic options with which you can start designing. Okay, so let's understand what is shown in the simulation. Okay, so this is spring, this is damper, this is basically wheel and the wheel center, after that spindle point. Okay, so let's zoom in a little bit. So this is not the UI is not that great, but our work will be completed finally. Okay, the simulation is proper. Okay, so you don't have to worry about that. Here we get to see the wheel center, wheel spindle point, then this is knuckle. See, this is knuckle. Okay, and it is the knuckle upper ball joint, knuckle roll bound child, and these are the arms, control arms. Okay, control arms and their joints. Okay, these are the pivots. Okay, and this is the tie rod arm, then tie rod joint there, and let's zoom out. Okay, these are two wheels. So this is about the components, and this blue point is uh, the roll. Okay, so roll point. Let's zoom it, and you can set here. Okay, so these are YZ, ZX, and YX. Okay, this is top view, this is side view, this is front view. Okay, so if you want to simulate this, you have these options like 2D bump, roll, 2D roll. Okay, and then 3D bump. Okay, so we have, for the simulation purpose, let's select the 3D bump, and then this option. Okay, animate mechanism. Okay, so there's error, I think. Okay, some error is there in the software for now. I'm not getting why it's happening. Let's check. Okay, so it's working fine for steer now. Okay, I don't know why it's working bad for bump and roll. Okay, so see, this is how you demonstrate it. Like, let's say it's side view and this is top view. You will see the same for not same. Okay, wait, not same. See, here the wheels are steering. In the roll, you will see it's rolling action, and you will see in bump that this line is going up and down. Okay, after that you have the options like fill in. Okay, only lines. So these are the visual options, right? And this is pan, this is zoom, and this is rotate. Okay, so this is open, save. Okay, then after that I'm just telling you the important functions, right? So we can after that there is spring option, damper we can hide. Okay, if you don't want, you can just hide it. And we can also see the hard points here, like, okay, so the points are visible, the coordinates are visible. Okay, and after that we can also do the vehicle. This is for bump and vehicle half. Wait, so these are all these options. We can see only half part, and just move it a little bit. I will check why it's not happening, and we will resume our video. Okay, yeah. Okay, so I just restarted the software, and sometimes it's happen in the Lotus. So there are bugs, so you will face the issues. So it's really important to save your data. Okay, just save as. Okay, so whenever you are iterating and you think it's really important to save those points on that simulation, just go for saving it and make the versions, because the Lotus might fail anytime. Okay, so it's really helpful if you save your data. Now you can see in the, let's go for the 3D bump. Okay, in the 3D bump we are seeing that the road is moving, and these points, the hard points, are fixed, and the wheel is moving up and down. There is also another option like the road is fixed and the vehicle is moving up and down. Okay, CG is moving up and down. In the roll, see, if the vehicle is rolling, let's go for 2. Okay, So now we are able to see both wheels, and this rolling center is going left and right as per the roll. Okay, in this bump, and finally in the steer as we have seen. Let's see the steer from top view. Okay, so this is steer. So this software is also helpful for designing a steering system. Okay, then let's discover more options. Okay, the wheel you can hide. Okay, these are the tie rod. Okay, these options are not that much useful. Just we use simulator now. Okay, after this we have simulated our vehicle. And then what next after that? Okay, what next? So with this tool we can find the point and its data like this. Okay, so this is point 1, it's x y z coordinate, then max x, max, minimum max, max x y z. Okay, that's also helpful. And I will just tell you what you have to do to get the report. Okay, to get the report, just go for STF. Here you will get your report. Okay, all the data will be shown here, like your static values. Okay, let's see where you can edit your static values. Static values are like when you're designing in suspension or steering, you just set the camber value as positive 1 or negative 1. Okay, it depends on your system design. You set the caster as 3, 2, or in some cases it might be 5 and 6. So how to edit those data? So here in the data we have a lot of options. You just go there and watch the features, which are the features available. Like in the mass data we got the CG properties. Okay, here we can put the part 1, then part 2, then part 3. Okay, so this we can put your data and apply. Okay. So do it on your own. Then we get the option to put the compliance data like bush properties, stiffness, spring properties. Okay, in the spring properties you can put the spring rate. Okay, the spring rate means stiffness, and all these things you will be having because you are ready with your design. So these are must things: damper properties, tire properties, roll bar properties. If you are using track properties, in the you can save the coordinates, and in the set the what you can say the static angles. Those are camber angle and the toe angle. Why camber angle and toe angle only? Because the caster angle is already included when we put the hard point coordinates. Okay, so according that coordinate the caster is taken. Okay, let's see, we can here get this. They see the caster minus 25. Okay, and then, okay, so the caster angle is 0.10 because it can be negative in the automobiles. If it's negative, then your design is a failure. So caster angle is 0.10. It depends on hard points. Okay, then additional things I want to tell you, like these are the body type. These are the additional things, parameter points. If you just go there, you can just see like in the view option. There are many things. Like, okay, so frequency is there. You can set the frequency of the vehicle. Then free body diagram you can also get. Okay, in the graphics you can hide and show these points. You can hide the visibility of CG. Okay, grid lines. Okay, and there are many things. Okay, so in the sol you can get the list of properties, setup, and also on the internet we get one document like getting started with the Lotus software. It's really helpful. Okay, and now let's come to the most important point. Okay, the graphs are really helpful because with the graphs we get to analyze things, because from the visual simulation like this we can't completely understand what's happening. So with the graphs we get to compare the parameters. like this, and you can auto scale it. See, just like you can see where it's droop, the camber was 0.7, and as the pump is rising, then uh, it becomes negative 1.6. Okay, you can iterate things and you can match the graphs with your analytical skills. You have to select the proper set of hardpoints and validate those again and again, and you have to finalize your design. So that's it about the Lotus Shark software. Wish you best for your design.